Hi all. Once again, welcome back to the chapter Triangles. Today, we will move on to the last lesson of this chapter, Inequalities in a Triangle. First of all, let us see the word inequalities. From small classes, we have seen what are equalities. For example, if you have 10 divided by 2, which is equal to 5. This is an equality because we have the equal sign. In another situation, when we have an equation, we write x is equal to 10, for example, or x is equal to 12. This is also an equality because we have the equal sign. Now let us see what is the meaning of inequality. Inequality means, I'll just give you an example, 10 divided by 2 is greater than 3. This is an inequality, which means it is not equal, but there is a comparison. Another example, x is less than -3. This is another example. To write equality, we have only one way, that is just to write equal sign. But to write inequality, we have 4 different signs. One, we can say less than, which looks like L. Less than L. Look at this one. The second one is greater than. Third, less than or equal. Greater than or equal. How do we represent it on a number line or graphically? If you want to write x is equal to 12, we can draw a number line. Let's say this is 0, 2, 4, 6, 8, 10, 12. So this is exactly the point x is equal to 12. But how do we represent x less than -3 on a number line? We have 0, for example, 1, -1, -2, -3. So from here, less than, 3 is not taken, less than means from here going back. This represents x less than -3. What's the meaning of less than or equal to? For example, x less than or equal to 2. We take the number 0, 1, 2, 3, like that. Less than or equal to means we have to take the number 2 and then less than. What does it mean when you write x greater than or equal to 0? So again, we have a number line. We mark 0 and 0 is included. This equal sign shows it is included. Greater than means we go forward. These are all some ideas which will help you to understand what is the meaning of inequality. So basically, inequalities include all these 4 signs. Let us see how does it work in a triangle. It's starting with a theorem. The angle opposite to a longer side. So first of all, from a given triangle, we choose a side which is longer. So of course, this will happen only in an isosceles triangle or in a scalene triangle. In an equilateral triangle, you know all the angles are equal to 60 degrees. We have discussed in the previous periods. So in this example, we have a scalene triangle. So here, first of all, we discover which is the longer side. AC is the longer side. Then the theorem says the angle opposite to, this is the side, and the angle opposite is only angle B. Angle A and angle C are adjacent angles. So angle B will be greater than, angle B is greater than angle A, as well as angle B is greater than angle C, because AC, which is the opposite side, is the longest. That is the theorem. A simple theorem. We just have to understand which is the opposite angle. Next, it says about the second theorem, which is just the opposite of it, which means we look at the largest angle. The largest angle from here is, of course, angle R, because angle R is obtuse angle. Angle Q and angle P are acute angles. So from the angle, just choose the side which is opposite to it, or figure out which is the side which is opposite to angle R, which is PQ. So definitely PQ is the longest, or PQ is greater than PR. Also PQ is greater than QR, because angle R is the largest angle. So the opposite side will be greatest or longest. Hope it's clear. Let's move on to one more theorem from this lesson, which says the sum of any two sides, we have to take two sides at a time, it is always greater than the third side. It actually applies the value in our life. Staying together is stronger. So whenever you take two sides together, it will be stronger than a single side. That's what the theorem says. For example, if this is an isosceles triangle with side 7 centimeters, and let's say this is 5 centimeters. We can choose any two sides at a time, and it will be definitely greater than the third side. Let us choose 7 plus 5, which is equal to 12. So we took 7 and 5. So we know that 12 is greater than the other side, 7. Again, we will get the same idea. If you take this 5 and 7, it's the same. We can write 12 is greater than the second 7. Or if you take the third side, which is 7 and 7, you know it is 14, and 14 is greater than the third side, 5. And this rule will help us to understand when we are given three sides, can this be a triangle or it can't be? Let us see it with examples. Which of the following can be the sides of a triangle? First question, 3, 5, 7. Here what we have to do is choose all the three cases. Between first and second, compare with the third. Between second and third, compare with the first. Between first and last, compare with the middle. Let us see. First and second, 3 plus 5 is equal to 8, which is greater than 7. So it is okay. Again, between second and third, 5 plus 7 is 12, which is greater than the other side, which is 3. It is okay. And the next one is first and last. 3 plus 7, which is 10, and you know 10 is greater than the other side, which is 5. If all the three are accepted, then we can say, yes, this can be, yes, these can be the sides of a triangle. Let us see another example. 4, 5, and 6. Can you pause here and try all the three cases? Well, let's continue. So 4 plus 5 is equal to 9, which is greater than the other side, 6. Again, 5 plus 6 is equal to 11, and 11 is greater than 4. And the last one is 4 plus 6 equal to 10, and you know 10 is greater than 5. So all are okay. So this is also can be sides of a triangle. Let us see another example. 9, 10, and 20. 9 plus 10 equal to 19, and 19 is not greater than 20, which means this can't be the sides of a triangle. What will happen if these are the sides of a triangle? Let us just try it roughly. One side is 9. Let us say this is 9. Other side is 10. Let us say this is 10. And the third side is 20, which is like this. Which means this is not a part of the triangle. That's why this is impossible. So this theorem lets us know just by looking at the numbers, can it be the sides or not? Let us see one more example. 7, 8, and 14. Case 1, first and second. 7 plus 8 is 15, and this is greater than the next side, which is 14. This is okay. Next one, 8 plus 14 is 22, is also greater than the other side, which is 7. This is also okay. Now let us take this first and last. 7 plus 14 which is 21, and 21 is greater than the other side, which is 8. All of them are possible, so this can also be the sides of a triangle. So this is really helping in our daily life to just to understand, can it be the sides of a triangle or not? Now time for an example. Here we are given D is the point on the side BC of a triangle ABC. D is a point on the side BC such that AD is equal to AC. These two sides are equal, which means triangle ADC is an isosceles triangle, and you know, in an isosceles triangle, two sides are equal. At the same time, two angles are also equal, which are the base angles. So let us say this is 70 degree, then this angle will also be 70 degree, just as an example. Now the question is to prove that or show that AB is greater than AD. So we have to consider the triangle ABD. In this triangle, you know, ADC is exterior angle. So first of all, we know that angle ADC is equal to angle ACD because they are the opposite angles of equal sides of an isosceles triangle. At the same time, we also know that angle ADC is an exterior angle, which means ADC is the sum of angle A and angle B. Do you remember the exterior angle property? Is the sum of interior opposite angles. We can't take the adjacent, but the opposite angles. So which means angle B plus angle BAD. So an angle is equal to one angle plus the other angle. So if you add a number, which means the other angle is larger. Just if you compare between ADC and B only, which means ADC is greater than angle B because I'm removing an angle from here. When you remove a positive number, the left side will become larger. For example, look at this one. 100 is equal to 70. 100 is equal to, let's say, 70 plus 30. So if you take only 70, 100 is greater than 70. This is the theorem that we apply here, or this is the fact that we apply here. Now we know that angle ADC is the same as ACD. So this can also be, or this is equal to angle ACB is greater than the right side. I'm just writing as it is. So which means when we compare between B and C, C is greater. If C is greater, which means the side opposite. What is the side opposite to angle C? It is side AB. Therefore, AB is greater than the side opposite to angle B is AC. AC. But by given condition, we know that AC is the same as AD. So we say AB is greater than AD because AC is equal to AD, which is given. That was what we have to prove. That's the idea in the inequalities, and we will just solve the exercise related to this in the next period. That's all for today. Thanks for watching and see you soon.